All right. Hello, and thanks for joining the next data science webinar. Today's topic is what every executive should know about data scientists or about data science. So if you're thinking about starting a data science program for your company, or you're interested in helping your organization make better decisions based off historical data and trends, then you're in the right place, because today we have an exciting and informative interview with Teknion Data Scientist, Dr. J. Kyle Roberts. We're going to explore how organizations are leveraging data science programs to gain a competitive advantage and provide better service to their customers. A few notes before we get started. This session is being recorded, and the recording, as well as any additional resources, will be emailed to you in the next day or so. Additionally, we will be launching a few polls during this session, and we encourage any feedback or engagement on these polls to help our presenters tailor their presentation to your interests and needs, because we definitely want this to be an informative and beneficial session for you. And lastly, we also encourage you to utilize the chat or the questions window found at the bottom of your Zoom screen to pose any questions you may have during this session, because we'd be more than happy to answer these as we go along. A few introductions. My name is Rachel Mason. I'm the marketing specialist here at Teknion Data Solutions, helping out with this series, and Technion is happy to be hosting this series as well as 3 other series on data pipeline, visual analytics, and strategy. So be sure to check out upcoming webinars, as well as check out our featured recordings. And with that, I'm going to pass it off to Teknion Data Scientist and Client Success Leader, Dr. J. Kyle Roberts.
Well, wonderful. We're excited to have everybody today. And so kind of how we're going to work through this is Dave and I are just going to have a bit of a conversation around some questions around data science and what it takes to get a program going, how programs start to mature and what they look like inside of your business. And so we're excited to do this. And so I'm going to go ahead and pass it off to Dave. And as it's going, just a little bit about myself, I think is maybe we're saying I'm been with Technion for about 2.5 years. Before that, was a professor, taught stats at Southern Methodist University, was doing research down at Baylor College of Medicine before that. And so and kind of one of those guys that was a stats guy that transitioned into data science when I saw the field starting to move that way. And so excited to kind of bring some historical expertise to this, and talking about maybe a little bit to the evolution of data science that is from that started back when many years ago, when it was it was either it was writing code in R in order to do things kind of the hard way. And now, as things have progressed and have a great opportunity to be able to kind of data science for everybody now. So anyway, let me pass it off to Dave, and then we'll get into kind of some of the content. So.
Awesome. Thanks, Kyle. And hello, everyone. Thanks for joining us today. My name is Dave Haas, and I'm on the sales team here at Technion. My focus and my passion, quite honestly, is around data science and the data science practice here at Technion. So as you can imagine, I'm super excited about this interview with Kyle. I think we've got some great questions lined up, but we'll also encourage you guys just to dive in, drop any questions that you have. And we've left a little bit of time towards the end to address all of those, as well as if any do pop in that are really right on topic for the question we have on hand. Rachel, please just drop those in and jump in and let us know, and Kyle will do his best to answer those. If you've attended any of our data science webinars in the past, you know that we typically like to do a real deep dive, or Kyle will do just an amazing job at diving deep into the tools and sharing real practical day-to-day advice on data science. Today, we're taking a little bit of a different approach. Today, we're going to focus on what you need to do to really start a program and be successful at implementing a data science program once it's started. So it's a discussion at the business level. We're going to talk about foundational groundwork, the needs really that you need to build to make your program successful. And before we do that, I wanted to just take a couple of minutes to dive in and give you a little bit of background on Technion. I know there's some folks that have not been on this series before, so allow me to do that. and then we'll dive right into the meat of our program. So essentially, Technion, if you're not familiar with us, is a data and analytics consulting company. We help our customers solve data problems that essentially are slowing the growth of their companies. And Kyle, I know you've been a data scientist with Technion for a couple of years now, and would love to hear your thoughts just on the mission and really why you decided to join Technion.
Yeah, so I think the mission is it. Like that was the big linchpin for me, is that it seems like everyone's data, there are some hidden truths buried in there, that helping people unlock those hidden truths really help progress a business and, produce a business that is 2x, 3x, 5x. After they discover, hey, here is that thing that was buried somewhere inside of our data, and uncovering that. And so, in that sense, I think a good data scientist and is a little bit of an archaeologist, right? So you start digging deep to try to see, where the truths that are. But part of it is not just digging in any direction; it's knowing where to dig and how often, and how deep to go. And so I think that's why I really got excited about Teknion, is that the mission is look, it's in serving, and that we any organization that has a servant's heart, I'm behind. But then in that second part, in that your data does have hidden truth in there, that sometimes it's easy to find, sometimes it's really difficult to find. But our idea of serving and helping you unlock that is, to me, that's the pivotal thing. We're not here just to bill hours. We're here to serve alongside you, and then also to help you unlock those hidden truths. Well, I know we'll get more into that later on. What does it mean to unlock those truths, and where, how do we know where to dig, so to speak? But and then what tools to dig with. But I think that is the crux of it. There is something there in your data, helping you find it, and then helping you unlock it so that it can be actionable. Is really just the heart of what Teknion is all about. So.
And Kyle, I think, one of the things I've heard you say in other webinars and just speaking with you in general is that you really do have a goal to help our clients become self-sufficient. I think that's kind of a big part of what you do, is not so much to try to create programs that are going to insert Teknion into a business for years and years to come, but really focusing in on what it takes to get some small wins and to build competency within an organization.
Right. No, I think you've said that well. That's to me, a terrible consulting organization is one that says, hey, you're going to need us forever. Like, you find a way to insert yourself and then stay there forever. You haven't done your job. I like working with groups that go, okay, that we identify, okay, here are the people at your organization that are going to be good at this, we can set them up as kind of success leaders. And sometimes that involves, putting together a center of excellence or something like that at an organization. But again, too, if you're constantly dependent on us, we haven't done our job. And so that's also in that kind of that serving mindset of we want to come in, help companies kind of move further down that trajectory of beyond maturity. And then into all right, you're doing this for yourself, and then able to do that. That's sustainable. Again, any practice for me, as companies are starting to think about, okay, we know we need to be doing data science. Bloomberg called this the new sexy data sciences, and I think they're right about that. But just I think the reason that it is taking off so well in some companies and failing at other companies is because it's not something that can be palated, if that's a word. I love inventing words. And so maybe if they don't exist, we'll put them together. But that can actually be swallowed by an organization. So it really frustrates me when, maybe we get inserted into an area and they say, hey, we hired someone that does data science, and they built us these models, but now we don't know what to do with them. It's not helpful, right? And so the idea behind data science that is palatable is really, that's what I'm passionate about, is that can you go and then replicate this back, and is it actionable? And Again, I think we'll get into this later on, but I think I heard some statistic one time, and I don't know how you measure this, but still, I think it's pretty true from what we've seen, is that 95% of all models that actually get built never get into production. That's not helpful for anybody, right? And so helping build a model is about 7 steps into a 100-step process, right? Really, we want to get that to where it's actually producing actionable results that anyone can use. I remember when I used to help when when I had grad students, and so I used to teach at the doctoral level. And one of the things that I used to say to my students when they were doing their dissertation is, "Hey, I realize, well, you did some really weird stuff. So multi-level, multiple membership models with logic transformations, and okay, it's all really hard. Yeah, okay, that's great, but you need to be able to explain it to your grandmother, right? Because when you get done with this, it doesn't mean anything to anybody if you've got this really complicated model that only 7 people in the world understand, right? And so there's got to be an analogy in there. There's got to be something that, and so actually one of my favorite students is he wound up taking a crazy complicated dissertation and he put it in terms of fishing, fishermen. And I was like, oh, this is the win. Like, that's the win. That's what we've got to be doing with data science. Because again, we can't expect that a CEO or a CFO or a CTO that necessarily is going to have all the stats background or something like that. We've got to make it to where it can be actionable. Okay. Yeah, I'm sorry. That's a big soapbox of mine. So that's wanted to spend some time there. But yeah.
That's perfect. That's perfect. Thanks, Kyle. So this is since this is a data science webinar, let's talk about Technion by the numbers. We roughly have about 60 folks on staff here. 75% of them actually hold a data and analytics certification. And we average about 26 years of industry experience, a lot of deep experience. Of course, 100% of our team is focused on helping our customers grow their businesses, as Kyle talked about. And we're just excited really to have you here today, Kyle, to talk a little bit more about the data science piece of the practice. Kyle, anything else you wanted to mention in this slide, or should we?
No. Let's get into it. Let's get into the tough questions and road mapping. Yeah, I'm excited.
All right, that sounds good. So here's our agenda for today. I have a few poll questions that I'd love to throw out for you guys. And Rachel, if you wouldn't mind, while I kind of go through the agenda, if you wouldn't mind putting the first poll question up, we can get some results out and share those with everybody. Great. Thank you, Rachel. Those are up. But essentially what we're going to do today is we're going to kind of start, first of all, a little philosophically. We're going to talk about how we think about data. And I think this is really important to set the rest of our interview up with Kyle. And then we're going to really get into a discussion around some of the most common questions that executives come to us and ask, and share those with you, and allow Kyle to kind of expand a little bit about how we respond to those questions. So great. Do we have any results yet on the survey? All right, fantastic. So Kyle, it looks like about 75% of our folks have a data science program, which is great.
Good.
So maybe perhaps a little bit deeper for those folks, and about 25% have not started yet, but obviously have an interest because they're here today.
That's great.
All right. Well, let's start. I love to put this slide up. At first glance, it is, it looks a little, it's a little complicated, but essentially when we think about data, we categorize it into what we call 4 pillars: data pipeline, data visualization, data science, which we're going to dive deep into today, and of course, data governance. But, Kyle, could you kind of help us maybe, in the spirit of what you said earlier about simplifying and making things a little more palatable? Could you explain this slide in terms of, what was it, to your grandma?
Yeah, absolutely. So I think the main thing to think about here is that if we're just looking at this in a lens of data science, is that we're really stretching data. I think a lot of time people think, okay, so I'm going to build out all my data pipelines, and then after we're done with that, we're going to do data science. But I think that's wrong to think that way. because as we're going to talk about here in a little bit, when we think about data science, that we always start with the question, right? We always start with the, what is it that you want to know? Well, the problem is if you are thinking about that in terms of what do I want to know, then those questions are really going to influence how you set up your data pipelines. And so, for example, let's take that we have some variable that is, let's say, for a 0 to 100 scale on, let's say it's an individual's knowledge test that we're giving them, and somehow we'll scale it 0 to 100. But we're storing that, instead of storing that as a number of 0 to 100, we're actually storing that as a binary object, that we store it as hey, it's a 1, 0. So here are the people that were above 70 mean they're passing versus failing. While that may be how someone is going to use that at someday in visual analytics, like here's the people who passed, here's the people who failed on this, the data scientist that is going to be incredibly frustrated by that, because the way we're storing that, we lose information there, right? And so we had this variable that was scaled pretty large, and now we're scaling it really small. And so if we're not thinking about data science throughout, instead of like, this is the thing we do at the end, we don't like it like that. So data scientists are going to they want to be involved in every aspect of that. They want to know, how's the visual analytics person going to use this data later? How are we storing it, and does that make sense to store it in the way that we're storing it? And again, too, data scientists always want more information. They never want less, right? Always wanting more information. And so that idea of this, it's silo that sits somewhere between the data pipelines and the data and the visual analytics. That to me is, I don't like thinking about data science that way. It needs to be from the very beginning all the way out to the visual analytics. Like there needs to be involvement of the data scientist in every stage of that, because you have to know how we're going to use it, and we have to know how it's going to come in. And so, hey, we need to store it this way, not this way, because here's how I'm going to actually run this through my stat method that I'm going to run. And so, for example, if you only stored it as pass and fail, I'm only going to be able to use, like, let's say logistic regression type techniques, when the suite of techniques that are open to me, if we'd scored that on an interval scale, is much better. So I hate it when, and I've had this before, is that I come to meet with the company and they go, hey, we're just going to send you our data. Would you analyze it for us? Oh, no, I won't. So I absolutely won't do that. And so, because I need to know, what is it you're wanting to do with this? And actually, how can we, because I can give you some results, but they may not be actionable. For example, there may be something that I'm measuring that, all of a sudden, the color of your hair is a significant predictor on something. I don't know what that would be. Well, actually, I do know what that would be. The color of your hair could be a significant predictor on whether or not you're going to have skin cancer, right? That could be, but you can't change people's hair color. And so they're saying, all right, analyze this. All right, well, here's the things that we're seeing, but I'm not saying go out there, okay, now here's your actionable result is to change hair color. We have to know what the suite of actionable results might be to us, and then we can actually inform that. So data science all the way across the entire thing. If you're thinking of we're going to pass the data off to this group, they're going to give us results and we're going to do something with it. Nope, you're missing it. And actually, too, that's my other encouragement. If you've got data scientists that they're all they want to do is build models, or they're just your stats type, you hired the wrong person. And so they need to be from the very beginning all the way through to the end. So yeah, that's why I like this slide, and I like how we're kind of data science is stretching this whole thing here. So,
in a way, Kyle, it's similar to data governance, right? That
absolutely.
And your entire process, not just the beginning.
Yep. And it's funny too, because we have David Hinderer is here at Technion. He and I work. I think he and I work more closely than any two other employees at Technion, because anytime he's doing data governance, he's in there he and I are talking about with a customer or a client. Then I'm talking with him about, hey, as they're doing the data governance, you may want to put these rules in place because it's going to impact data science, and then vice versa. But I would think data governance is actually the overarching. If people, if someone was coming to us and they were saying, hey, we want to get going in data science, but they don't have a data governance practice going yet, probably encourage them to start the data governance first. Because that's going to impact, those rules are going to impact how we're going to do data science in the future. And so, yeah, what data we're going to have access to, and especially if you're a healthcare organization, like all the HIPAA laws that need to be, because you just can't hand that information to your data scientist, right? That with HIPAA, there's got to be some rules around that. So those working hand in hand, we're starting to really, and this is just something we're coming into this year, is that we may think data science may be a subcomponent of data governance. We're still kind of trying to flesh that out. But yeah, that's why I like this slide. Yeah.
Thank you. So, I mean, with that in mind, I think data science classically has traditionally been very difficult to define and wrap their arms around for most companies. I know we get a ton of questions from people that span from the basic to the very, very in-depth. But, for example, for a manufacturer, data science might be all about optimizing shipping and logistics. If you're in banking or finance, it might be about deploying data science to detect consumer fraud. Healthcare, another application, right, for predicting disease. But as a data scientist, Kyle, how do we wrap our arms around this? How would you define data science?
That may be the $1 million question, right? It's how do we define this? And also too, I did notice there's a question in the Q&A, how do you automate data science models? I am going to get to that. So that's a really, really good question. So I promise I'll come back to that. And if I don't, Dave, start throwing stuff at the screen to remind me. Okay. So the data science question, like, that's a really good one. In fact, we met with an organization the other day that actually they do testing for licensure for different things, like if you want automotive licensure or things like that, different areas that have licensure. And then they asked me, they said, hey, what are you seeing out there for data science? And there's not a lot. Like, it seems like anybody can kind of put out their shingle and say, hey, I'm a data scientist. So I will say this, though. I think that, so there's that question of what is data science and then what is a data scientist. I think that the ask of the data scientist right now is a big one, right? Because it's not just typically, I think, and seen in the question that was just asked about, how do we automate these models? I think what a lot of people have tried to do is say, I'm a statistician, I want to reinvent myself as a data scientist because the pay scale is a lot higher, right? So, which is, I mean, hey, power to you, right? But the problem is I think the data scientist needs to be not only good at the statistics part and building model part, but then kind of the workflow of I know how the data is going to be stored and where it's going to be stored and how to automatically feed that into a model so that model's consistently pushing out really simple, actionable results from those things. I think that's where data science is going. It's not enough just to be able to build a model anymore. It's be able to build a model that is quick, that is easily actionable, that produces actionable results that anyone can interpret. That's where data science is going, right? And you have to be, if you're with a bank, you have to also be able to talk model risk management for the bank and those type of things. So it's not enough anymore. Data science has gone beyond, I can build a statistical model. Now it's, can you build a statistical model that can be easily implemented, that we can automatically feed data into, and then also that produces actionable results. But then on the second part on that is that can the data scientist actually be able to tell the organization, we've been collecting data XYZ. We need to include also this ABC data in there because that's going to help us further. So like I'm not getting enough information from what we have. I need to be able to enrich my own data. We'll say with like Experian data, or maybe you're doing site selection, so we need to pull TomTom in or something like that. Or Dun & Bradstreet data needs to be enriched in there. So being able to also pull in those enrichment things, it's a big ask. And I think part of that too is when we're thinking about data science for an organization, we're not thinking about a data science person, because like I'm good at some of those things, but when it gets down to, hey, all these API calls to automatically, put this thing out where it's going, full, I'm not good at that. But who is? Matt Agee on our team. He's really good. So we work great together. And so I think when you're building a data science practice, you're thinking about, hey, here's the statistician that I need. They can build the models. Here's the person that can implement those models. They're really good at API calls, doing model management. And then here's the one that's helping me think about the data lifecycle that's producing into this. Okay. And sometimes you can get that in a single person. I mean, they're incredibly skilled. That's a really skilled individual, but we're thinking about data science. We're way beyond just, hey, I can build you a statistical model, way beyond that. Yeah.
Excellent. So I think this is kind of an interesting one to touch on. Gartner recently put together some of the biggest challenges that they are seeing when they do their surveys, the top challenges that organizations face as they start to deploy or want to deploy data science programs. Will you help kind of unpack this one a little bit? Maybe.
Yeah, no, this is great. And I love that you pulled this one in, because here's the part, the biggest thing I'm going to say on this one. If you look in the bottom left corner, it says source 2018 Gartner AI and ML Development Strategy Survey. Okay. I think that this has changed in the last 2 years, right? I think number 2 is now replaced number 1. Fear of the unknown, the enterprise maturity. So this whole skills of the staff, this is where this question that came in over the discussions is really, I think really needs to be addressed here, or the Q&A that was asked is, how do you automate data science models? So the problem is that the skills of the staff is starting to go away because the skill of the software is now replacing the skill of the staff. So if you have, here's a great example. So I was doing a demo for a company with Data Robot, and with the company asked me, the one we built, I mean, Data Robot, in a few minutes can build 70, 80 different models, compare them against each other, make sure that, you're doing best practice on all of those. And so one of the people that we're doing the presentation for asked me, they say, Kyle, if you did this yourself, how long would it take you? And I go, to build all 80 or to build like the top 10 and then really flesh them out and do all that is done here? And they said, oh, let's go with the top 10. And I go, I don't know, 4 months, right? And I did it in a matter of minutes just by clicking a button. And here's the deal too, with the stuff that we're doing with Data Robot, is that it's the way I would have done it. Like it's done well. The cross validation is right. The way they're thinking about variable transformation and feature fitting and all of those things are the way I would have done it, and it's right. And so the skill of the staff right now is not as important. So we can come into an organization that maybe doesn't have a stats-based data scientist there, and we can go, hey, we can get you out. That skill of staff is not as important anymore. We can take an analyst, make them a citizen data scientist with just a few weeks of training, right? And so, but the thing that is killing companies right now, in my just from the companies I've worked with, is this fear of the unknown. That number 2 is huge, because there's just, it's terrifying to say, hey, we built this system and now we're going to let the box tell us what to do as an organization, right? That's terrifying. I mean, it reminds me of my daughter's a pilot, and she actually is training other pilots right now. And she said the other day, they were coming into land, and her student pilot literally locked up, like grabbed the, staring at the ground, didn't know what to do. She locked up and she couldn't, her student couldn't make a decision. And so what she did is she just took her hand and she reached up and she covered her student's eyes. And then as soon as, she covered his eyes, he let go, and then she was able to land the plane. And she said, it was kind of terrifying, but there's that, it was just the fear of the, oh my goodness, we're in a plane and we're at 130 knots or however fast they were going. We're coming against this we're about to land on the ground, right? student became terrified. I think that same thing is there. Everyone, for the first couple of iterations of data science with the with like a C-level executive, there's a sense in which I'm reaching across and I'm going, I got this, just let go. So, you know, for that first time, I'm covering your eyes and going, let me do it. All right, just let's let it go. That's scary. And I think that's the trouble, is that why data science is so challenging. Man, I've got, you know, especially with, you know, let's say smaller banks, we may be working with a C-level executive who has 35 years of experience. And we're saying, I need you to cover your eyes and let me run with this just once or twice. Let's just see how it does. Yeah, that's terrifying. Absolutely terrifying. And and so I think there's a point at which, though, we're going to start seeing C-level executives who do have experience with data science and are starting to trust that. But for right now, it's just the fear of the unknown. I'd be terrified too. Like if someone came to me and just goes, hey, let's take all of the experience that you have for the last 35 years and we're going to hang on to that, but we're going to set it to the side just for a second, right? Let's try this. Man, we're coming in for a landing. I don't trust it. Okay, I understand. I understand. It's hard. It's very hard. Yeah.
So key takeaway from this one is don't let the fear of the unknown freeze you.
Yes, that's exactly right. But boy, I don't know. I mean, that's easy to say. It's hard to do. You know, again, you're coming in for a landing. That's a hard surface, and you're going really fast. You know, so that's tough. That's really tough.
Yeah. Awesome analogy. So I love it, and that's a grandma-friendly explanation.
Okay, thanks. Yeah.
So I love this slide. This is what I was hoping to chat with you a little bit about, Kyle. And I know you said earlier, you kind of alluded to this, but you know, I think the big question that we feel from a lot of execs around data science is that, you know, does it really make sense to start a data science program before you are further along on this data maturity curve? And maybe you could just talk a little bit, one, about the curve itself.
Yeah. So I'm going to give here's the teaser, because here's the answer. There's no better day to start data science than today, right? You need to start today, even if you're not ready to put it to use. I love this curve because there are those that are, look, they're culturally unaware. They haven't even moved to a tactical place with their data. But the data scientist can give you, and you can get so many headaches out of the way by involving the data scientist, even if you're at that, boy, everything lives in Excel right now. Okay, that's fine. As we're starting to build a data warehouse system, get the data scientist in there to say, build it this way, not this way, right? And because that's, yeah, from data architecture, you really need a good architect, but you also need a data scientist to say, hey, when I'm going to use this later, this is how I'm going to use it. I need you to store it like this, right? And so even if someone is completely unaware in their organization, they're new startup, just don't know how to do, you know, don't even understand the vocabulary, that's okay. Involve the data scientist there, because there will come a day when you'll regret not having done that, because you may have to restructure a whole bunch of stuff that you're doing with your data, right? But even if you're at that strategic level, okay, so to me, it's bad to think about, all right, we're ready to start doing predictive analytics, right? I don't like the way that, I just don't like that thinking. I think you always need to be thinking about, it's someday at the future, we're going to be doing predictive analytics. What do we need to do to get there? And how do we need to set up our data in order to get that? So for me, data science runs through all five, right? It doesn't matter what stage you're at, you need to be thinking about data science, because at some point you want to get there. And so, yeah, if you're at level one, it may be that the data science conversation is only once a month. That's great. And you don't need a data scientist, right? You just need a couple hours of consulting. People will look over your shoulder. But someday you're going to be at level 4, and having that framework set up. I mean, it's the same thing as building a house. You want to go deep with the foundation, and having that deep foundation is involving that data scientist from the very beginning. We know we want to get to this point. Here's the questions we want to be able to answer. Okay, what type of data are we going to have so that when we're at that point, we'll be able to answer that question.
Excellent. Excellent. Thanks, Kyle. I appreciate you elaborating that a bit on that. So here's the big one, the $1 million question. How do you actually get started?
Yeah, that is the $1 million question. So and the answer is, oddly enough, you start with a question. I think too many times people go, hey, we're doing like, if we're in marketing, we may say, hey, we're doing marketing and we need to do a cross-sell model. Like I've actually had this with a bank once. They go, hey, we need you to build us a cross-sell model. And then I go, okay, can totally do that. Yep, not a problem. We can build cross-sell, or like a next best offer model. Okay, to totally do that. That's not a problem. All right. However, so that's always my big however. What is it you want to know? Like, what do you want to know at the end? Well, what we want to be able to sell more product. Okay, great. You want to sell more product. So what we want to do is we just want to have more people in our products. Okay, great. Well, after a long conversation with them, they didn't need a cross-sell model. What they needed to do was actually do analytics to find out who in the regions where the bank were like the customers that were buying the products that they already have. Because what had happened is they had already oversaturated all of their current customers that were at the bank. And so they had been hitting them with so many things. And so they were trying to go back to the same well to get more water. What they needed to do was drill more wells. And so that was a different, and so through the business, we were able to say, guys, I wouldn't do cross-sell because you've so saturated your people. I mean, this is how many things they're receiving from me. But here are other people like the people that are not at your bank. Here are other people that are like the people who are at your bank, and you should start reaching out to them. Okay, they started doing that. They didn't need the cross-sell. That's the model that they needed. And so again, we always start with a question. We never start with the stat model, but a lot of times people, and also too, you'll find data scientists that are like this, like, I'm really good at multi-level, multiple membership models. That's great. And it's like that, man, I've got a hammer and everything's a nail and I'm just gonna start smashing it, right? That's bad, that's bad. Always start with a question. What is it that you wanna know? And we usually start with, the question we like to ask businesses is, what is the thing that if you knew right now would make your business better in 6 months? And they go, oh, yeah. Every C-level executive knows the answer to this. They probably have 3 answers to it. What is it that if you knew it right now would make your business better? Okay, if we knew this, great. Let's start with that. And then we go into, do we have the data for it? Again, we're not even getting to the model yet. Do we have the data to be able to answer that? And is the data in the right format? Meaning that, okay, to answer that question, I'm going to need this type of data. It's going to have to be this way in order to be able to answer. So yeah, for example, like if you want to predict changes in the stock market and you're only capturing the data at the end of the day, right, you're losing a lot. And so you need to probably be able to capture it, moment by moment, maybe every 3 seconds or whatever, in order to make those decisions. But if you're only capturing at the end of the day, you don't have the data in the format you need to be able to make good decisions about it. And then you build your model. Okay, then you build after that. It's the last thing that you can do. Yeah.
So start really, go for a small win. Start with a question that what would
That's
change?
A great one. Yeah, do start with a small win too. Yeah.
And then the only other piece that I think you touched on a little bit, but it's all about, it's not only having the data, but it's the data in the right format, right? Yeah. Which is another big piece to it. Well, great. Well, you mentioned hammer, having a hammer and everything's a nail. Let's kind of go there. Let's talk about the tools. But
good. Let's talk about the tools.
Yep. Yeah. Before you dive into the tools, though, Kyle, Rachel, I think we have another question. Our second of 3 questions for the audience. If you could pop that one up. Awesome. So here our question is, what areas of data science are you most interested in? And you can select as many as you like. And then we'll share the results once you guys have answered that question. And Kyle, if you'd like, while they're answering the question, maybe you can pop into the tools section.
Yeah, I will. Although my favorite on this one is the poll question here is that gaining access to your data. That is so funny to me because that happens so often. That there's, you have the data, but no one will let you have it. So that one's the one that's just, it's so frustrating.
All right. Well, let's see how that.
Yeah, I'm curious if that's the smash in your head one. It's not as bad. Just a couple people on that. So yeah, getting access. But that one is the funny one to me. I'm just like, let them have the data, So, yeah. Well, and even too, I had a conversation this is funny. I had a conversation one time, and I said, hey, can you just, their data was in Snowflake. And I'm like, can you just give me a read only? No, we don't want you changing anything. Wait, I want read only. Like, I can't change it if it's read only. No, you may accidentally change something. Oh, it's very frustrating. So,
they went through a little sandbox to play in.
Yeah. So
All
creating models to make predictions. Okay, that's a good one. That's a good one. Creating models. Yeah. So
Kyle,
let's talk about that.
Yeah, maybe you should go through this slide. Maybe we address.
I think the tools is a good one because, and it does relate to that, creating models to make predictions, because the problem is that, yeah, if you don't have the right tools, you can't make models. So yeah, Rachel, if you can close that, and then we'll talk about. Oh, that was actually on my end. Yeah, never mind. I can close it myself. So what tools are required? This is great. Let's talk about the really hard but really popular tools first. Okay, the really hard ones. Most of your data scientists love building things in R and in Python. And if you're not familiar with R, it's just the letter R. It's a really great programming language, really high stat level. So they love building things in R or in Python, or even sometimes in SAS. Like if you have SAS is crazy expensive now. I'm not the biggest fan of SAS just because the entry level is so high. It's just so expensive, right? So I think there is a problem here, and this is what I would say. If you're a data scientist out there, this is the thing you need to watch out for. And then if you're trying to hire data scientists, this is the thing you need to watch out for. We tend to be a really arrogant bunch. I mean, that's just, as data scientists, we just are. We're just an arrogant bunch. I don't know why. Well, I guess I do know why. I mean, it's the same reason that a cardiologist is an arrogant bunch, right? That a lot of times the stuff that we can do, not a lot of other people can do. And so if there's some job security in being the person, being the wizard behind the curtain, right? That nobody else can do it, only you can do it. So if you're a data scientist, you've got to get out of that. You've got to stop doing that. And then if you are if you're an executive and you're trying to hire somebody, man, being able to code in R and Python and even SAS or even MATLAB or something like that, that's great, right? But can you translate all that stuff to something else? And I'll say this, and I think probably data scientists will get offended by this, but that's okay, because I don't find it offensive at all. Data Robot a tool like Data Robot, and again, there's lots of other tools out there like this, but Data Robot can do what you can do faster and better. Because if we were to pull up Data Robot right now and I were to run some data through it, we would see, it's going to come back with like 80 different models. The funny thing is on those, and we're all being honest with ourselves on those, even though, I taught PhD students in stats. Of those 80, I could build 15 of them. Like the other 65, some of them I haven't even heard of, right? I'm just like, with early stopping, man, I've never done a model with early stopping. I don't even know what that is, right? And you look at it, and so I think that's where we have to be honest with ourselves. Those tools, because they're done correctly, it doesn't require me to do code as much anymore. Or I need to build, and this is why I love Alteryx. Okay, Alteryx is by far my favorite, because I can build a model inside of Alteryx now that's a really complicated model. And then any of these buttons that if you see there, like I can now create a button that everybody in my organization can use. And I can build it in R, I can build it in Python, it doesn't matter. But now I can, in essence, this toolbar up on the top, I can create a button that everybody else in the organization can have. So it can say, again, we can get down to this, hey, this is Kyle's weird k-means tool, right? That does k-means the way we need it done and gives us the results that we need to get out of that, okay? I can build that in R. In fact, I have done this, right? In fact, and also too, I didn't like the regression tool inside of Alteryx, so I changed it. And so I built it the way I would want the results to look, the analysis that I would want. Now I can package it up and everybody can use it, right? Whereas if I say, yeah, send me your stuff, I'll run it through R and then I'll give you the output, that's not helpful to anybody. And so if you've got data scientists that aren't giving you, I mean, if they're like, yeah, you have to send it to me and then I'll run it for you, oh, I fire them. So maybe I shouldn't say that too long, but at least have a conversation with them that, look, we're way beyond that. We're way beyond that. The tools now enable, gosh, and here's the frustration. These tools let me 5X myself, right? Now I can build, I mean, now I can say, all right, here's the functionality or here's the model and it exists inside here and I can pass it off to someone else. And then now I don't have to babysit the model anymore either. I mean, anybody can start to do this. Inside of Alteryx, you can use, you know, we can actually look at that model to be deployed out there to everybody else. Again, Data Robot has a really good tool for doing model monitoring. We can do the model monitoring inside of Python, inside of Alteryx. We've got to get past that. I'm the guy that builds the models and everybody has to send me their data. And then I turn that around. Those days are gone. They're not helpful anymore. You know, there used to be a day when you had to build it inside of R, or you had to build it inside of Python. Now you can build it inside of Python and then package it up. That's what needs to be done. So tools are required. Yeah, so it's a short list, right? There's SPSS. I'm not the biggest fan of SPSS. There's SAS, there's R, there's Python, there's Alteryx, there's KNIME, there's Data Robot, there's RapidMiner. I mean, there's TangentWorks now has the best time series tool I have ever seen. And here's what they did. This is how smart they are. Time series tools are hard to use. So they created a button inside of Alteryx. That's brilliant. Now all I have to do is drag it down onto my canvas and I can use it, right? Really, really smart. The best time series tool I've seen out there. It's really, really impressive, okay? So there are those tools, but they have to be tools that everyone can use, not tools that only the data scientists can use.
Awesome, thank you, Kyle.
I feel strongly about that, in case you didn't pick up. So I definitely have an opinion about that. Yeah.
So we want to leave a little bit of time for our audience to ask questions. So as a reminder, please pop your questions in the Q&A, and we will do our best to get all those. But just in a couple minutes on this one, Kyle, who needs to be involved?
So you got to have C-level buy-in, or else the models will never get used, right? But also, too, you need a translator, and sometimes that's not your data scientist. You need someone that can say, here's this really complicated model and here's what it means, right? Here's how we'd use it. I love, so we here at Technion, we have 2 Tableau Zen Masters. And if you don't know what that is, that's like the best of the world at Tableau. Both Josh and Bridget, who are here, Bridget and I did some work actually for Data Robot, where we took the outputs of these crazy complicated models. And man, she built these dashboards that are just ridiculous stellar. And anyway, it doesn't matter that if you don't understand what the model did, you could use the dashboard and actually get really actionable results. You have to have a good translator, right? And so that sometimes that can be your data scientist. It's kind of hard to wear both of those hats, but you need someone who can translate all those results. And so we don't have models that don't make it into production. Yeah.
Outstanding. Okay, well, before we dive into Q&A and give you guys a chance to invite some questions, keep this coming. We've got some good ones coming in. We would like to offer out to everyone that's on this webinar an opportunity to actually spend some time with Kyle, one-to-one. We offer what is called a design thinking whiteboard session. And really what these are is they're opportunities for you to actually sit down and talk about your big ideas. Talk about any problems that you're facing. I know that half of you from the survey already have a data science program in place. Maybe you need an outside opinion. This is a free opportunity to get to spend a little bit of time. And as Kyle said, to have somebody maybe look over your shoulder and kind of see what you're doing and get some new ideas. So if you'd like to take advantage of that, please go ahead and just send us a quick note. And I think you actually have a poll that asks that question, Rachel. If you could put that up, you can answer that question. And if you answer yes to it, we will reach out and try to schedule one of those for you over the next couple of weeks with Kyle. Fantastic. Okay. Kyle, we did have a few questions come in that
Okay.
we want to ask you. One of them is, how do I budget for a data science program, not really knowing what it will cost?
Oh, that's a super great question. Yeah, data scientists are expensive, unfortunately. This is, yeah, they just are. So, so I think the first is this, is that I think what's really helpful is to what Dave, you mentioned earlier, is start with small wins, right?
Right.
The so starting a data science practice it is tough because it's going to be expensive, but the data scientist should be able to come in and say, hey, here are ways that we're definitely going to either save the company money or make the company money. And if you're not, I mean, I would think most data science practices that I've worked with at other companies, they're generally thinking about themselves in terms of 5x. Like if a data scientist costs 200,000, they should be saving or making the company an extra $1 million a year. It's generally how we've seen people think about this. I think when Bloomberg wrote about I think it was Target, an executive they hired to do some data science work, and in her first year she wound up saving the company some ridiculous amount. I mean, it was like 20 or 30 million just by some of the projects. Now, again, not everybody's going to knock it out of the park like that, but that was pretty good. And so, yeah, I think though that you have to put together it's really about building a roadmap around, hey, we think this is how much we're going to, I would never say just do data science for data science sake. When we're working with a company and they say, hey, we realize we need to start doing data science, the first thing we say is, okay, let's start with building out a roadmap. Like, let's see what are the business needs. Like, we would never just say, okay, here's, hundreds of hours and it's going to cost you $200,000 and we'll start building right away. We would never do something like that. We would always walk in, let's spend a small amount of money. Let's really dive deep into because it may be that we go, hey guys, y'all are actually at level 1, or maybe level 0. We'd love to do data science with you, but first you got to get your data in order. And here's how you do that. And so I think they do come expensive. But they should also be able to produce 5x is not that's not unthinkable. Definitely not unthinkable. Yeah.
Here's a good one. I know you had mentioned time series and your recommendation to work with TangentWorks. The question basically is, can you help us with data prep for time series?
Yeah, that's a hard one because you really do have to be storing data correctly to do time series. And so and then there's a whole question about how do we store the covariates that are related to that. If you haven't looked at this, if you are doing time series type analytics and you haven't heard the term data vault yet, I would start looking at that. Like, how do I store my data? How do I get it to where I'm going to be ready to do time series? I love the way data vaults think about storing data. It's easy for me. If somebody says, hey, we're doing time series and I've got it in a data vault, I'm like, oh, 2 thumbs up. I know it's going to be right. It'll be really easy to go to analytics on that. And so that may be something, if you need help kind of looking at what does a data vault look like and how do we store that data, that is a difficult thing to do, to store data for time series or to think about storing data for time series. Would love to chat with you about that because and here's the hard part. Most people store data in columns, and so they're like, okay, here's day 1, and then here's day 2, and then here's day 3, and then here's day 4. The problem is that you actually have to pivot that like this to where it's here's day 1, here's day 2, here's day 3 in order to analyze it. And so the way you store it is typically not the way you're going to analyze it. Because just of the way and then putting covariates in there also, it just makes it more difficult. That's where a tool like Alteryx is really, really helpful because we're storing it this way, we're going to analyze it this way, but we don't need to rewrite code every time we add a new day's worth of data. You just need it to be all automatic. So that's a great question. It's not an easy answer. It kind of depends on how you're storing it and where you're storing it, and how do we pull in the other covariates into that, because in some covariates are what we call time altering, or time dependent covariates, meaning they change as the data changes. And then some of them are like, okay, this person always has brown hair, for the most part. So those don't change. They're time non-varying covariates. So yeah.
Well, Kyle, I think we have just about hit our limit on time. Thank you so much for the questions and for responses today. It was amazing. If you guys have any additional questions, want to reach out, here's my email. We'd love to hear from you, and would love to get some feedback on this webinar from you as well. Thanks so much.
Yeah, thank you, everybody. We really appreciate your time today.
Yep. And just a reminder, everyone, this session was recorded, and we'll send out the recording as well as this presentation deck. I did see a question if we could share this deck, so we'll include that as well in the email that'll come out about either today or tomorrow. So thank you again, Kyle and Dave, for your time. It was a very informative session. And like Dave said, if you guys have any additional questions, feel free to reach out to us here. So thank you so much.
Thanks.
Thanks.